So, hello guys, in this video we'll look how quicksort algorithm works. So before jumping into quicksort algorithm, I want to give a small description about what is sorting. So sorting is nothing but arranging elements either in increasing order or decreasing order. So you have given an array of elements which are in random order, that means not in sorted order. So we need to sort the array in ascending order. So using quicksort algorithm, let's see how we are going to sort, how quicksort algorithm works. So quicksort algorithm is basically divide and conquer algorithm. These are the key points we need to remember when it comes to quicksort algorithm. So the first thing is it is a divide and conquer algorithm. Divide and conquer algorithm is nothing but we divide the problem into the sub problems and we solve that sub problems and conquer. Conquer means we are going to merge the sub problems and get the resultant output. The main idea behind quicksort algorithm is to select an element and put that element in its sorted position. So what is a sorted position? So the sorted position of an element is nothing but the position where all the elements on the left side of that element are smaller than it and all the elements that are right side of that element are greater than it. So in this case, in quicksort, we are going to call the element that we are going to select as pivot. So which is called pivot, or some people call it pivot, but whatever it is, so we are going to select that pivot element and we are going to move that pivot element or rearrange that pivot element in such a way that all the elements on the left are smaller and all the elements on the right are greater than it. So that is called a sorted position of the pivot element. So after putting the pivot element in its sorted position, we are going to partition the array. That means the left partition of the pivot element after sorting and the right part of the array after sorting. So I'll explain you clearly with this example. So what we are going to do? So we do this partition process recursively in quicksort. So let's see the example clearly. So in this case, we have an unsorted array and we are going to perform this partitioning operation on the whole array, on the complete array. So when we say complete array, it has a lower bound and it has a higher bound. That means this is the range of elements that we are going to perform the partitioning operation. So here the 0th index is low and the last index of this array is high, that is the 6th index. So in this example, we are going to select the first element as the pivot element. So we can select any element as a pivot element, like the first element or the last element or the middle element or the random element, anything can be selected as a pivot element. But in this example, we are going to see the first element as a pivot element. So here, first we choose the pivot element. Now this pivot element should be placed in a position where all the elements on the left are smaller and the right are greater. So for that, what we are going to do is, we are going to take two pointers. One is, let's say, first pointer called I, which is pointing at the first index of the array, and the other pointer as J. Now what we are going to do? We are going to increment I until the element at I is less than or equal to pivot element. And we are going to decrement J while the element at J is greater than pivot element. So once again I'll repeat. We are going to increment I while the element at I is smaller than or equal to pivot element. The element, we are going to decrement J while the element at J is greater than pivot element. So in this case, let's increment. So now the element at I is the pivot element, which is equal. So we are going to increment I. So the now element at I is smaller than or equal to pivot element. So increment I. Now the element at I is not smaller than or equal to pivot element. So what we are going to do? Next, we are going to decrement j. Why? It is greater than the pivot element. So 5 is greater than pivot element. Decrement j. We are going to check. The element at j is greater than the pivot element. So decrement j. Now the element at j is not greater than pivot element. It is less than pivot element. So we are going to stop decrementing j. So now we are going to swap the element at I and element at j. So 8 comes here and 3 comes here. So repeat this process while I is less than j. So I is still less than j. I is 2, j is 4. So these are pointers are nothing but they are pointing to indices. When I say I, it is the value of the index. So I is pointing to 2, j is pointing to 4. The element at 2 is 3, the element at 4 is 8. So now I am repeating the process. What is the process? The first step is increment I, while the element at I is less than or equal to pivot element, and decrement j while the element at j is greater than pivot element. So here I is smaller than pivot element, so increment I is still smaller than pivot element, so increment I is greater than pivot element, so stop incrementing I. Now start decrementing j. So j is greater than pivot element, so decrement j. J is not greater than pivot element, so we stop decrementing j. Now, so do we need to swap I and j? No. We need to swap the elements at I and j only when I is less than j. Now I has crossed j, so we are not going to swap. So come out of the loop, come out of this process, and what we need to do is we need to swap the pivot element with j. Okay, so now the pivot element, when you swap it with the element at j, that is the sorted position of the pivot element. So if you see here, I'm going to swap 1 here and 4 comes here. So if you see, all the elements on the left side of the 4 are smaller, all the elements on the right side of the 4 are larger than 4. So now we placed the pivot element in its sorted position. So next what we are going to do after doing it once. So we are going to partition this array into 2 parts. One is the left part after sorting this pivot element and the right part after sorting this pivot element. So then our pivot element is sorted. So this is the correct position, the sorted position of the pivot element, which is also called partition index. So that is what we remember in this partitioning. So partition index is part of this partitioning. So the sorted position is nothing but the partition index. So when we found the partition index, we have to break this array into 2 different partitions. That is the left part of the partition index and the right part of the partition index. This part and this part, right? So that means, let's say this is the partition index pi. So you're going to perform the same operation recursively from low to partition index minus 1, that is 0 to 2, and partition index plus 1 position to high, that is 4 to 6. So let's divide this and see what happens, how it looks after partitioning. So this is 1, 2 and 3. here is 8, 7 and 5. Now here the lower bound of this partition is here and the higher bound of this partition is here. And again the lower bound of this partition is this and the higher bound is this, that is first and last elements of the partition. Now we are going to perform the same thing. Select a pivot element, that is the first element of this partition as pivot, and take 2 pointers, which is pointing to low and other one is pointing to high. Now perform the same steps until increment I until the element at I is smaller than or equal to pivot. So here this is smaller than or equal to pivot, so increment I. So this is not smaller than or equal to pivot. Decrement j while it is greater than pivot. So this is greater than pivot, j comes here. This is greater than pivot, j comes here. So the pivot element is already at jth position and I has crossed j, that means j has crossed I, vice versa, anything is same, but now I is not smaller than j, I is greater than j. So we come out of the loop and swap the pivot element with the j index. So here both pivot and j are at the same position, so there is, when we swap also it will be the same. So again partition this array, that means the left part of the partition index, this is the partition index pi, that is 0th index, the right part of the partition index, that means left part it has nothing, so it is like null, and the right part has 2 and 3. So this is how similarly we perform the same operation on this partition. Again this partition will be divided into small partitions and the same operation will be performed on the smaller partitions. So hope you understood how quicksort works. So remember these key points. We are recursively doing this partitioning and placing that pivot element in its sorted position. So quicksort is an in-place sorting. So we are not taking extra memory to sort this array. We are just sorting the array in place within that array by performing some swappings, performing some rearrangements. We are going to sort the array. So let's look at the algorithm, how it works. Whatever we discussed, let's write a pseudocode. So partition method has an array as input argument, a lower bound and a higher bound, right? So what we are doing in partitioning, we are going to select pivot, that the first element as pivot, that means the element at lower bound as a pivot. So pivot is equal to array at lower bound, right? Next we are going to take 2 pointers which is pointing to the first element of the partition and the last element of the partition, that is I is equal to array at low, j is equal to array at high. So we did 2 things. After taking 2 pointers, we are incrementing I while the element at I is smaller than or equal to pivot element. So that's what we are going to write here. While array at I is smaller than or equal to pivot, increment I, right? And next we are going to decrement j while the element at j is greater than pivot, right? J minus minus. And then after doing these 2 operations, we are going to swap the element at I and element at j. So swap element at I and element at j, right? But this swapping is done only when I is smaller than j. That means I should not cross j. So one condition we are going to write about this swap operation, that is if only if I is smaller than j we are going to swap, otherwise no need to swap, right? This operation is performed while I is less than j. Until I crosses j, we are going to repeat this operation. We are going to increment I, decrement j and swap I and j. Why? We are going to perform this operation while I is less than j, right? So after performing this operation, when j crossed I or I crossed j, we come out of the loop and we are going to swap the pivot element with j, with the element at j. Swap. Pivot element is nothing but array, the element at low, right? The first element. So low with array at j. These two we are going to swap. After swapping, this method, partition method, is going to return. It will return an int. So this returns the partition index. Partition index is nothing but where we have placed this pivot element. So we place this pivot element at j, right? We are going to return j. So this is the whole responsibility of this partition method. So now we will see how quicksort is going to call this partition method recursively. So quicksort takes three arguments, input arguments, an array, a lower bound and a higher bound, right? So what quicksort does initially, the one condition we need to check in quicksort is the lower bound should always be less than the higher bound. So though we increment it, though we decrement it, so we need to make sure that low is always smaller than higher bound. So that is the case. So if, as we are doing this recursively, when there could be a chance where low can be higher than the higher bound, the lower bound can be greater than the higher bound. So that is what we are going to check here. If lower bound is less than the higher bound, so I'm calling it bound, but I'm writing here low and high because I cannot write bound, it becomes too big, so that's why I'm calling it. Don't get confused. So if and only if low is less than high, I'm going to perform a recursive operation where I'm going to call. How would I know the partition index of the first? Initially we are going to perform this partitioning on the whole array, the complete array. That means initially from the lower to higher, right? So that's what we do. Partition, we are going to call this function partition of array, comma low, comma high. This is what we are going to pass. After getting this, function returns a partition index, right? So this partition index later is used to partition and perform the steps again. So that is what we will do here. Again, we are going to call this quicksort function recursively. Quicksort of array. So what is the part that we have called? If you recall, the partition in lower bound to the partition index minus 1 and partition index plus 1 to the higher bound. So that's what we are going to do here. Low to the higher bound, that recursively which calls here is partition pi minus 1. And again we are going to call for the right side partition. So quicksort of array, that is partition index plus 1 to high. It's done. Quicksort is as simple as this. So this sorts the array. You just need to call this function from your driver code, that is the main code or your main function, saying that quicksort of whatever the array you have initialized, comma 0 comma array dot size or length, whatever it is, -1, the last index we are going to pass, and this function is going to sort the array in place. Hope you understood this.